Again, the previous recording was interrupted, so I uh, record the second part. In the previous video, I discussed simple XY space, and I said this entity V is defined as x1 I plus y1 j. So what it means is that this entity is a mixture of I and j basis vectors. These are constructors of the space. I mean, this is I and this is j. And x1 is a number and y1 is a number. And so it means uh, this vector is defined as actually as such. Okay, I'm going to build on top of this concept. I mean, mathematicians do that all the time. They generalize concepts. For instance, they say, what if instead of I and j, which are simple unit vectors, something more abstract is used, something, for instance, like E I theta, and that is a wave. It's not important. I mean, mathematically, it's not important what it means. That is just a wave. Uh, and so instead of these bases, this is basis and this is basis. Basis. This is I unit vector in the x direction, and this is j unit vector in the y direction. And mathematicians say, okay, what if instead of I and j, one uses this as the construct of space? And they define, for instance, this entity, this f of x, this is some function, this is some entity defined in the space constructed by these basis vectors, f of x equals Cn, and Cn is basically just coefficients, something like this x1 and y1. This x1 and y1 are numbers, these are called coefficients. Similarly, this Cn is just coefficient, this is just number. And E, I, and x, and multiple sum over all possible n. And this is just summation. So this is a different type of space. I mean, uh, these are coefficients analogous to x, y, and y1. E, I, and x is basis analogous to I and j. And this is a more abstract space. The idea is the same. I mean, the idea of space constructed by basis vectors persists. I mean, in this example, basis vectors are very simple. I and j, these are straight lines, straight vectors, very simple basis vectors. But in this example, bases of this space are actually way more complicated. They are waves. So the point I'm trying to make in this video is that mathematicians generalize. They start with a very simple concept, something like this very simple space, x var space, x and y space. And they generalize this concept and say, okay, what if instead of this space, we use something else other than I and j, other than I and j. So basically, they evolved the idea of this simple space into a more abstract space. So evolution is not new in mathematics. Mathematicians do it all the time. And that is very common in mathematics, to evolve a concept and to build on top of it and to produce a more abstract concept. So the takeaway from this video is that evolution is not new in mathematics. It is used all the time, and yeah, that was the point I was trying to make in this video. So in the next videos, I will talk about logic again, and I will continue discussing about these topics. Thank you very much for watching.